In GCP, VMs are placed in regions and zones, similar to AWS with its regions and availability zones. But a network is broader than a VPC. It's a global resource that spans all regions in a given project. It contains one or more subnets like VPCs, but each subnet spans a region, not just a zone, and the IP address it defines spans an entire region. As each instance is added to a subnet, it gets a private IP address from its subnet's range along with an optional public address, just like it did with AWS. But with GCP, the subnet spans a region, so you can move VMs anywhere in a region, not just an availability zone, and keep the same address. This gives you a broader footprint for operations like load balancing and fault tolerance. Like AWS, routes describe how outbound traffic is directed to its destination using a target or next hop. When a subnet is created, it automatically adds a route that enables instances in its network to send traffic to its destination addresses. It specifies the virtual network as the next hop. By default, a route applies to traffic coming from all instances in a network. If desired, you can limit this to a subset, like a subnet, using instance tags. Two key differences are: 1. Each network spans all regions, so there's no need to create additional networks to route traffic globally using internal addresses. 2. There's only one global routing table. As long as you keep instance addresses distinct across networks, you can route traffic between networks using internal addresses by connecting them with a VPN tunnel and adding routes that point to the tunnel. Firewall rules govern which instances can communicate with each other. They're bound to instances like EC2 security groups. However, you can tag instances during spin-up so you can group them with firewall rules. You just have to define the groups. EC2 offers NACLs to cover subnets, but groups in GCP can be arbitrary. We'll cover that in another module. Finally, each network comes with a default Internet gateway, which you can use to add a route to the Internet so instances can see hosts outside GCP. Before adding instances, each project comes with a default network that includes a subnet in each region, a default Internet gateway that routes to internal subnets and the default Internet gateway, and firewall rules allowing traffic between internal hosts and all outbound traffic and incoming pings, RDP and SSH. All other incoming traffic is blocked by default. When you add VMs, they're added to the default network unless you specify otherwise. So all you have to do is pick a zone and an optional external IP address. And GCE puts the VM in the subnet and picks an internal IP address for you. So with GCP, just like AWS, you can configure large multi-tiered applications with isolated services and reduced attack surfaces. Here's an example of an app with a front-end web service behind a public firewall and a back-end app service behind a private firewall, each using multiple VMs. We'll show you how to set this up later. You can also add NAT or Bastion servers at the perimeter or VPN gateways to external networks. Like AWS, you'll need to set up the gateways and add VPN routes. The key difference is that Compute Engine offers farther out-of-the-box reach with global networks, regional subnets, and a default Internet gateway that does not require VPC peering. Therefore, networks are more global in Compute Engine and more isolated in EC2 by default. If you want to reverse these, you can. It just requires some setup. And almost anything you can do in one, you can do in the other. You can also define multiple networks per project for added flexibility. We'll cover this in more detail later. For more details, see the GCP for AWS Professionals document under the following link. Here is a list of key GCP terms and AWS equivalents with scopes highlighted in blue. Now, let's spin up some VMs, look at the default network, and test their connectivity.